Hi everyone, I'm Doug Black at Inside HPC. We're at the ISC 2025 conference in Hamburg, and we're at the VDURA booth talking with Volker Lindenstruth. He is director of the Center for Scientific Computing at Goethe University in Frankfurt. And so today we're looking at how the center's AI physics program pairs one of Europe's largest AMD GPU clusters with VDURA's new V5000 data platform to push the frontiers of scientific computing. So, Volker, if you could, let's start off, tell us a little bit about your position at the university.
Well, I mean, as a center of scientific computing, we have to support all the different user groups. We have more than 50. We are also a site of the National High Performance Computing in Germany, so we have all German sites which can use our machine. Large spectrum, and of course high performance computing needs also mass storage, and the new VDURA system is going to be our core storage facility, which will grow up to become larger and larger. Already today it is a very high performing system, which is what we need, and it's also an extremely reliable system, which is of very high importance for us, because obviously losing data is not something which we are looking forward to.
Okay, so what AI physics problems are you exploring, and why do they place pressure on the data infrastructure?
Most applications have very large amounts of data to process. We are using also artificial intelligence in various areas. For instance, we just won an excellence cluster where a digital twin of a human cell is being built, and there artificial intelligence is being used to train boundary conditions for models which are then developed further to use it. In particle physics, we have various areas where we use AI algorithms, for instance, to reconstruct hits, help in the reconstruction of tracks, and so forth. So it's a very large spectrum of different applications which all have to be supported by us.
Okay. Now, before VDURA came into the picture, tell us about the issues, challenges, maybe some of the limitations of the previous environment and how VDURA addressed those issues.
More performance, more reliability, and an idea which I believe has very good potential to grow to much, much more scale than what we have now.
Okay, and tell us about VDURA's multi-level erasure coding and data reliability.
That's a unique feature which I'm very keen to have. Obviously, reliability is a big issue. And if you go into multiple petabytes mass storage, restoring data from tape is a theoretical option, but not something anybody would be looking forward to, because tapes are slow. So the best thing is you don't have failure. And multi-level erasure coding basically has erasure code also across all of the storage systems, so there is absolutely nothing in that system which can fail and therefore lead to a loss of data, which is obviously a fantastic step forward. And that is paired with very high performance, which is something which we need anyway.
Okay, and tell us about some of the other deciding factors for VDURA.
Performance, cost. We're a university, we're not very rich, so cost is always an issue. So it all came together, making a lot of sense. An excellent technology, which is at the cutting edge of the market, together with outstanding performance. And it has been delivered. We are extremely happy with a joint effort, bringing it all together in our data center.
Okay, and what does future expansion look like for your needs and use cases?
My plan is to basically coalesce all the mass storage of the university at this mass storage close to the high performance compute servers, which makes a lot of sense because there it is where it's needed. We are increasing the network performance of the entire university as a backbone so that everybody has very fast access. Target is something like 400 gigabits per second. And of course, we are coalescing all the large numbers of individual private storage systems which you have at the university. You would be surprised how large the number is, into one system which can be much easier maintained.
Okay, so what's the big takeaway so far, and what advice to others would you give to those who are looking to modernize their storage environments?
I mean, we are very happy. The installation went smooth, the system is set up, it's running, and it is performing very well. And it is a fantastic start to coalesce and improve the mass storage capabilities of a site.
So, Volker, you mentioned performance. Do you have any specific numbers you can share with us?
For example, 670,000 metadata rate performance or 8.4 million IOPS in the system as it stands today, and this performance will increase as we enlarge the system.
Okay, great. So we've been with Volker Lindenstruth of Goethe University, talking about data infrastructure and scientific discovery. Thanks so much for your time, and we'll be watching for future milestones.
Great pleasure. Thank you.